Now, in this lecture, we will find the area of the green circle. In the drawing, we have triangle ABC with side AB that equals to 13 units, side BC equals to 15 units, and side AC equals to 14 units. And we have the green circle that it is inscribed in triangle ABC. Side AB of triangle ABC is tangent to the circle at this point. We will define the point of tangency between side AB and the circle as point D, or point D is also the launch point between tangent AB and the green circle. And we know also that side AC of triangle ABC is tangent to the circle at this point. We will define the point of tangency between tangent AB and the circle as point E. And side BC of triangle ABC is tangent to the circle at this point. We will define the launch point as point F. Point F is the launch point between tangent BC and the green circle. Okay, and in the next step, we will define a new term that is actually, the term is the semi-perimeter of a triangle. So what is a semi-perimeter of a triangle? Semi-perimeter of any triangle equals to the perimeter of a triangle over 2. Okay, semi-perimeter of a triangle equals to the perimeter of the triangle over 2. So actually, if we have triangle ABC, and we know that side AB of this triangle equals to A units in size, side BC of the triangle equals to B units in size, and side AC of triangle ABC equals to C units in size. Then the semi-perimeter of this triangle equals to, first of all, we mark the semi-perimeter with the letter S, that is abbreviation for semi-perimeter. So S, that is the semi-perimeter of this triangle ABC, equals to the perimeter of triangle ABC, that is actually the sum of its sides, that is A plus B plus C, over 2. Okay, so the semi-perimeter of this triangle ABC, S equals to A plus B plus C, that is the sum of its sides over 2. Okay, so we can calculate the semi-perimeter of our triangle ABC according to the formula of the semi-perimeter, that the semi-perimeter of any triangle equals to the sum of its sides. So first of all, we will define side AB as A that is to say AB equals to A, AB equals to A, and A equals to 13 units, and we will define side BC of triangle ABC as B, that is to say BC equals to B and BC equals to 15 units, so B equals to 15 units, and we will define AC as C, that is to say AC equals to C according to our definition, and C equals to AC, that equals to 14 units, so C equals to 14 units, so A equals to 13 units, B equals to 15 units, and C equals to 14 units. So the semi-perimeter of any triangle equals to the sum of its sides, that is A plus B plus C over 2. And the semi-perimeter of our triangle ABC equals to A, that is 13, plus B, that is 15, plus C, that is 14, over 2. So actually the semi-perimeter of our triangle ABC equals to 13 plus 15, that is 28, and 28 plus 14 is 42, and 42 over 2 is 21, so I'll write it down. 42 over 2 is 21 units. So the semi-perimeter of triangle ABC equals to 21 units. Okay, again, the semi-perimeter of our triangle ABC equals to 21 units, and in the next step we will find out the area of triangle ABC according to a special formula. We have a special formula that is actually the area of any triangle can be calculated according to the following formula that states that area is abbreviation for A is abbreviation for area. The area of any triangle equals to the root of S, that is the semi-perimeter of the triangle, times S minus A. A is the size of one of the triangle's sides, times S minus B. B is the size of the triangle sides, times S minus C. C also is the size of one of the triangle's sides, so we can calculate the area of any triangle according to this formula, and we can calculate the area of any triangle according to this formula. We know that the semi-perimeter of our triangle S equals to 21 units. We also know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So we have all the variables of this formula, so the only thing that is left is to put the data inside the formula find out the area of our triangle ABC. So the area of triangle ABC, A equals to the root of S is 21 units, S minus A is 21 minus 13, S minus B is 21 minus 15, S minus C is 21 minus 14. So the area of our triangle ABC equals to the root of this expression. 21 minus 13 is 8, 21 minus 15 is 6, and 21 minus 14 is 7, so I write it down. So the area of our triangle ABC equals to the root of 21 times 8 times 6 times 7. Okay, so the area of triangle ABC equals to the root of this expression. Actually, the outcome of this multiplication is 7056. So the area of triangle ABC equals to the root of 7056, and the root of 7056 equals to 84 square units. So we found out that the area of triangle ABC equals to 84 square units. After we found out the area of triangle ABC, we will find the radius of the green circle. First of all, we will define the center of the green circle as point O. Point O is the center of the green circle. Then we will connect together points A and O by a straight line. And then we will connect together points B and O by a straight line. And we will also connect together points O and C by a straight line. So actually we created 3 small triangles. Triangle AOB, triangle AOC, and triangle BOC. And the sum of the areas of the 3 small triangles equals to the area of the big triangle ABC. So we will create a formula that states that the sum of the areas of the 3 small triangles equals to the area of the big triangle ABC. But first of all, we will draw 3 radiuses of the green circle that start from the center of the circle, that is to say from point O, and touches the circle at the launch points that are points D, E, and F. So the first radius will start from the center of the circle and will touch the circle at point D, that is the launch point of the point of tangency between tangent AB and the circle. The radius is marked by R. The radius of the green circle is marked by R. So as you can see from the drawing, this radius is actually drawn to the launch point, point D, and it is actually touches the launch point, that is point D. Then we will draw the second radius that starts from the center of the circle, that is to say from point O, and touches the circle at point E, that is the launch point between tangent AC and the green circle. Okay, as you can see, this radius is also drawn to the launch point, that is point E, and it is actually touches the launch point. Okay, and we will draw the third radius from the center of the circle until it touches the circle at the launch point, that is point F. Again, this radius is drawn to the launch point, point F, and it is actually touches the launch point F. Okay, and we have a rule, I will call it rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius at the launch point. Okay, I will read rule number 1 again. Rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to the launch point. Okay, to the radius drawn to the launch point. So I will read rule number 1 again. Rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So actually, rule number 1 states that whenever you draw a radius that is drawn to the launch point, then that radius will be perpendicular to its tangent. For example, this radius is drawn to the launch point, point D. It actually touches the launch point, point D. Therefore, according to rule number 1, this radius is perpendicular to its tangent AB. That is to say, this is a right angle, and this is also a right angle. The same thing about this radius. This radius is actually drawn to the launch point, point E, and it touches the launch point. Therefore, according to rule number 1, this radius is perpendicular to its tangent AC. That is to say, this angle is a right angle, and this angle also equals to 90 degrees. And the same thing we can say about this radius. this radius is drawn to the launch point, point F, and it touches the launch point, point F. Therefore, according to rule number 1, this radius is perpendicular to its tangent BC. That is to say, this angle is a right angle, and this angle also equals to 90 degrees. Okay, so now, as I have already told you, we will create the equality that states that the area of triangle ABC that equals to 84 units equals to the sum of the areas of the small triangles, triangle AOB, triangle AOC, and triangle BOC. Okay, so we will create the equality that states that the area A is abbreviation for area of triangle ABC, that we have already found out that it equals to 84 square units, equals to the sum of the areas of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. So it equals to the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Again, the area of triangle ABC, the big triangle, equals to the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Okay? So, actually, what is the area of triangle AOB? The area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of triangle AOB will be equal to the base of the triangle, that is AB, times the height to the base. The height must create 90 degrees with the base AB, and you can see, as you can see here, the radius indeed creates 90 degrees with the base AB, so therefore the radius is the height of triangle AOB. So it is the base times that is AB times the height, that is the radius, over 2. So actually the area of triangle AOB equals to the base of triangle AOB, that is AB, times the height to the base, that is the radius of the green circle, over 2. And what is the area of triangle AOC? The area of triangle AOC equals to the base of triangle AOC, that is actually AC, times the height to the base. The height must create 90 degrees with the base, and the radius creates 90 degrees with the base AC. Therefore, the radius is the height of triangle AOC, so it is the base AC times the height, that is the radius, over 2. So the area of triangle AOC equals to AC times the radius over 2. Okay? And what is the area of triangle BOC? What is the area of triangle BOC? The area of triangle BOC equals to the base of triangle BOC, that is BC, times the height to the base. The height must create 90 degrees with the base. So the height is the radius, because the radius creates 90 degrees with the base BC. So it is the base, that is BC, times the height to the base, that is the radius, over 2. So the area of triangle BOC equals to the base BC times the height to the base, that is the radius, over 2. Okay? But what is AB? AB equals to A And what is AC? AC equals to C. And what is BC? BC equals to B. So in total we got that 84 equals to AR over 2 plus CR over 2 plus BR over 2. Okay. Here we will take out a common factor R over 2 out of this expression. Again, we will take a common factor R over 2 out of this expression. We will get that 84 equals to the common factor that we took, that is R over 2. And inside the brackets, here we will have A, here is C, here is B. So in total we got that 84 equals to R over 2 times A plus C plus B. But what is the value of A? A equals to 13 units, B equals to 15 units, and C equals to 14 units. So in total we got that 84 equals to R over 2. In the brackets we have 13 plus 15 plus 14. 13 plus 15 is 28, and 28 plus 14 is 42. So I will write it down. We got that 84 equals to R over 2 times 42. So we got this equality that states that 84 equals to R over 2 times 42. So 42 over 2 is 21. So we have this equality that states that 21 times the radius of the green circle equals to 84. So here we will divide this equality by 21 in order to get the value of R. So actually R will be equal to 84 over 21, and 84 over 21 is 4. So we found out that the radius of the green circle equals to 4 units. Again, we found that the radius of the green circle equals to 4 units. After we found out the radius of the green circle, it is very easy to find out the area of the green circle, because the area of any circle equals to pi times the radius of the circle squared. Okay, so this is the formula for the area of any circle. It equals to pi times the radius of the circle squared. We've already found out that R equals to 4 units, so we can substitute R by 4 units in this formula, and we will get that the area of the green circle equals to pi times R square. R is 4, so R square is 4 square. So the area of the green circle equals to 16 pi square units. Okay, the area of the green circle equals to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, again we found out that the area of the green circle equals to either to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so in the next step I will show you a second method to find out the area of the area of triangle ABC. Okay, so I will present to you a second method to find out the area of triangle ABC. Again, I will present to you a second method to find out the area of triangle ABC. Okay, actually we will use the law of cosines in order to find out the area of triangle ABC. So what is the law of cosines? The law of cosines. First of all, I must emphasize that the law of cosines valid in any triangle. You can use it in any triangle. So in any triangle, if you have triangle ABC, and size AB of triangle ABC, the side of side AB of triangle ABC equals to A units. The size of side BC of triangle ABC equals to B units. The size of side AC of triangle ABC equals to C units. And we also know that the angle between side AB and side BC is angle theta. So according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay? Okay, again, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Again, we can use this equality in any triangle. So actually we will implement the law of cosines in our triangle ABC. So I will draw again our triangle ABC. So this is our original triangle ABC, and as you can see, in this equality, the only missing variable that we have is cosinus theta, because we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units. So we will implement this equation in our triangle, and we will find the value of cosinus theta because it is the only missing variable. So what is the value of C squared? C squared is actually C equals to 14 units, so C squared is 14 squared is 196, equals to A squared. A is 13, so A squared is 169, plus B squared. B is 15, so B squared is 225, minus 2 times A times B. 2 times A is 13, B is 15, so 2 times AB is 390 cosinus theta. Okay, so we got this equality. So 169 plus 225 is 394. So I write it down. Okay, 196 equals to 394 minus 390 cosinus theta. Here we will subtract 196 from this equality, and we will get that okay, so we got that 0 equals to 198 minus 390 cosinus theta. Here we will add 390 cosinus theta to this equality, and we will get that 390 cosinus theta equals to 198. Okay, so here we will divide this equality by 390 in order to get the value of cosinus theta. So we will get that cosinus theta equals to 198 over 390. Okay, we found out the value of cosinus theta. It equals to 198 over 390, and it is actually equals to 0.507962. So cosinus theta equals to 0.507962. Actually, we want to find out the value of theta itself, so we will operate the inverse function of cosinus on the outcome in order to get the value of theta. The inverse function of cosinus is r cosinus, so r cosinus of 0.507962 equals to 59.49 degrees. So the value of theta equals to 59.49 degrees. Okay, so we actually found out the value of theta. So we can write here that theta equals to 59.49 degrees. Okay, and then in the next step we will draw a perpendicular to side BC of triangle ABC from point A. So this is, we will define the touching point between the perpendicular to side BC as point D. And this angle is 90 degrees, this angle is also 90 degrees. So AD is actually the height of triangle ABC when the base is B. So we will mark the height with the letter H. So actually triangle ABD is a right triangle. Therefore, sinus of 59.49 degrees equals to H over A. Okay, sinus of 59.49 degrees equals to H over A, but sinus of 59.49 degrees equals to 0.8615 equals to H over A equals to 13 units. Okay, so here we will multiply this equality by 13 in order to get the value of H. That is the height of triangle ABC. H equals to 13 times 0.8615 is 11.2 units. So we actually found out the height of triangle ABC when the base is B. Okay, so the height of triangle ABC equals to 11.2 units. Now we can easily find out the area of triangle ABC. The area of any triangle equals to the base of the triangle times the height to the base. Over 2. So this is the formula for the area of any triangle, and the area of triangle ABC according to this formula will be equal to the base of the triangle, that is B, that equals to 15 units, times the height to the base, that is H, that equals to 11.2 units. As you can see here, the height H, that is AD, creates 90 degrees with the base BC, therefore the height is indeed H, because it creates 90 degrees with the base BC. So it is 15 times 11.2 over 2. So the area of triangle ABC equals to 15 times 11.2 over 2. And 15 times 11.2 is actually 168. And 168 over 2 is 84. So the area of triangle ABC equals to 84 square units. Okay, the area of triangle ABC equals to 84 square units. So we found out the area of triangle ABC in the second method. So in the next step we will find out the area of triangle ABC in the third method. Okay. So it is a third method. To find out the area of triangle ABC. Okay, I will present to you a third method to find out the area of triangle ABC. Okay, so in this method we will divide triangle ABC to two triangles. So we will divide triangle ABC to two right triangles. Okay, and by dividing triangle ABC to two right triangles, we actually will prove that the height of triangle ABC is 12 units if the base is 14 units. And we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of triangle ABC will be equal to the base, that is 14 units, times the height to the base, that is 12 units over 2, that is 14 times 12 over 2 is actually 84 square units. Okay, so we'll start to draw the two right triangles that have been created by dividing triangle ABC to two parts. Okay, so the first part of triangle ABC will be the following right triangle. The hypotenuse of the right triangle will be equal to 14 units. Then we have two sides. This side is 5 units, and this side is 12 units, and this is a right angle. So this is the first part of triangle ABC. We will prove that this is a right triangle by showing that it obeys to the Pythagorean theorem, the squares, that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, 13 square equals to 12 square plus 5 square. 13 square is 169 equals to 12 square, that is 144, plus 5 square is 25. And indeed 169 equals to 144 plus 25. So in this way we prove that this triangle is a right triangle, and the main issue is that we prove that the height of the triangle is 12 units if the base of the triangle is 14 units. So the second part of triangle ABC is the following right triangle. It has sides with 12 units, then it has the hypotenuse that is 13 units, and also it has a side that is 9 units, and this is a right angle. And we will also prove that this is a right triangle by showing that it obeys to the Pythagorean theorem, that 13 square equals to 12 square plus 9 square. 13 square is one. No, I made a mistake. The hypotenuse is actually 15 units. So 15 square is 225 units. That equals to 12 square, that is 144, plus 9 square is 81, and indeed 225 equals to 144 plus 81. So this is also a right triangle. So I can show you that if we combine these two triangles together, we will get the original triangle ABC. We will have here this side is equals to 13 units. This side is 15 units, and this side that equals to 14 units, and also we have again, if we combine these two right triangles together, we will get the original right triangle. So this is the triangle that we will get after we combine these two triangles together. So this is the original triangle ABC. And again, in this way we showed that if the base of triangle ABC is equals to 14 units, then the height to the base equals to 12 units. Because of the fact that this segment line creates 90 degrees with the base that equals to 14 units. So we can easily find out the area of triangle ABC, because we know again that the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of triangle ABC will be equal to the base of triangle ABC, that is 14 units, times the height to the base, that is 12 units. Again, the height creates 90 degrees with the base, so this is indeed the height over 2. So the area of triangle ABC will be equal to 14 times 14, or 14 times 12 over 2. 12 over 2 is 6, so the area of triangle ABC equals to 14 times 6, and 14 times 6 equals to 84. So the area of triangle ABC equals to 84 square units. Okay, the area of triangle ABC equals to 84 square units. So we showed you in a third way that the area of triangle ABC equals to 84 square units. So in the next step I will show you a second method to find out the radius of the green circle. Okay? The second method to find the radius of the green circle. Again, I will present to you a second method to find out the radius of the green circle. Okay, actually, in any circle that it is inscribed inside a triangle, we can use the following equality. In any circle Okay, so in any circle that it is inscribed in a triangle, the following equality is true, that the radius of the circle that is inscribed inside the triangle equals to the area of the triangle that contains the circle over the semi-perimeter of the triangle that contains the circle. Okay, it is true, this formula is true for any circle that is inscribed inside the triangle So we can implement this equality in our circle that is inscribed inside triangle ABC. We know that the area of the triangle ABC equals to 84 square units. We found it in 3 different ways. And the semi-perimeter of the green the circle of the triangle ABC equals to 21 units. Okay, we know that the area of triangle ABC equals to 84 square units, and the semi-perimeter of triangle ABC equals to 21 units. So we know that delta, that is the area of the triangle ABC, equals to 84 square units, and the semi-perimeter of the triangle ABC equals to 21 units. So 84 over 21 equals to 4 units. So the radius of the green circle equals to 4 units. And we know that the area of any circle equals to pi times r squared. R is the radius of the circle. We have the formula for the area of the circle. Here we found that r equals to 4 units, so we can substitute r by 4 units, and we will get that the area of the green circle equals to pi times r squared. R is 4, so it is 16 pi square units. Or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, so the area of the green circle equals either to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. So now I will summarize the lecture. Actually, we wanted to find out the area of this green circle, and we have triangle ABC, and inside triangle ABC we have the green circle that is inscribed in the triangle ABC, and we have 3 launch points between the triangle and the circle, point E, D, and F, and we want to find out the area of the green circle. So first of all, we defined a new term that is called the semi-perimeter of a triangle. The semi-perimeter of any triangle equals to the perimeter of the triangle, that is the sum of its sides over 2. Okay, again, the semi-perimeter of any triangle equals to the sum of its angles over 2. Okay. So we found the semi-perimeter of our triangle ABC, that is actually equals to A plus B plus C over 2, the sum of the sizes of its sides over 2. Okay, this is actually A plus B plus C over 2, and the semi-perimeter of our triangle equals to 21 units. And then we calculated the area of our triangle ABC, by using a special formula for the area of a triangle, that is actually this formula that states that the area of any triangle equals to the root of S times S minus A times S minus B times S minus C, when S is the semi-perimeter of the triangle, and A, B, and C are the sides of the triangle. And we use this formula in order to find out the area of triangle ABC, and we found that the area of triangle ABC equals to 84 square units, according to the formula that I showed you. And then we found the radius of the green circle by dividing triangle ABC to 3 small triangles, triangle AOC, triangle AOB, and triangle BOC. And then we drew 3 radiuses that starts from the center of the circle and touches the circle at the launch points. Actually, those 3 radiuses are drawn to the launch points between the green circle and its tangents. And we have rule number 1 that states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So whenever you draw a radius that is drawn to the launch point, then that radius will be perpendicular to its tangent. So this radius is perpendicular to its tangent AC. This radius is also perpendicular to its tangent AB, because it is drawn to the launch point, that is point D. This radius also drawn to the launch point, that is point E, and this radius also is drawn to the launch point, that is point F. Therefore it is perpendicular to its tangent AC. Therefore this is a right angle and this is also a right angle. So then we created the formula that states that the area of triangle ABC equals to the sum of the areas of the 3 small triangles. The area of triangle ABC equals to the sum of the areas of triangle AOB plus the area of triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Okay, and the only missing variable that we have in this equality is the radius. So we found out from this equality that the radius of the green circle equals to 4 units, and then the area of any circle equals to pi times the radius of that circle squared. We know that r equals to 4, so the area of the circle equals either to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Then we found in the second method the area of triangle ABC according to the law of sines. In any triangle, C square equals to A square plus B square minus 2 times AB times cosinus theta. This is angle theta. So actually we implemented the law of cosines in our triangle ABC. The only missing variable that we have here is cosinus theta. We know the values of A, B, and C, and we found out that cosinus theta equals to 198 over 390, or cosinus theta equals to 0.507962, and we operated the inverse function of cosinus on the outcome in order to find out the value of theta. The inverse function of cosinus is arc cosinus, so arc cosinus of 0.507962 is 59.49 degrees, so theta equals to 59.49 degrees. Okay, so we found out the value of theta. Then we draw a perpendicular to side BC of triangle ABC. This is a right angle, and we know that sinus theta equals to h over a, or sinus 59.49 degrees is 0.8615 equals to h over a, and a equals to 13 units. Okay, so we substituted a by 13 units. Then we multiply this quantity by 13, and we find out that the height of triangle ABC equals to 11.2 units. Okay, this is equal to 11.2 units, and it is the height of triangle ABC because it creates 90 degrees with the base BC. So the area of any triangle equals to the base of the triangle times the height over 2. And we know that the base of triangle ABC equals to 15 units, the height equals to 11.2 units. So the height times the base is 15 times 11.2 over 2. It equals to 84 square units. So we found in the second method that the area of triangle ABC equals to 84 square units. Okay, then I presented you a second method to find the area of triangle ABC. We actually divided triangle ABC to two right triangles, and in this way we proved that if the base of the triangle is 14 units, then the height to the base is 12. So the area of any triangle equals to the base of the triangle times the height over 2. So the base is 14, the height is 12. So 14 times 12 over 2 is the area of triangle ABC. So the area of triangle ABC, according to the third method, equals to 84 square units. Okay, and then I presented to you a second method to find out the radius of the green circle. Actually, in any circle that it is inscribed inside the triangle, we can use this formula that the radius of the circle that it is inscribed inside triangle equals to the area of the triangle over the semi-perimeter of the triangle that contains the circle. And we can implement this formula in our drawing because we have in our drawing a circle that is inscribed inside triangle ABC. So the radius of the circle will be equal to the area of triangle ABC that contains the circle over the semi-perimeter of triangle ABC. So the area of triangle ABC will be equal to the radius of the circle will be equal to the area of triangle ABC over the semi-perimeter of triangle ABC. So the area of triangle ABC is 84 square units, in the semi-perimeter of triangle ABC equals to 21 units, so the radius of the green circle equals to 4 units. And then we found out that the area of the circle equals to pi times the radius of the circle square, so, and we know that r equals to 4, so the area of the circle equals to either 16 pi square units, or in terms of numbers it equals to 50.265 square units. Again, the area of the green circle equals to either 16 pi square units, or in terms of numbers the area of the green circle equals to 50.265 square units. Okay, thank you very much.